So we've got these fantastic new toys, giant ground-based telescopes with adaptive optic systems that allow you to de-blur the atmosphere. Now, surely the time has come to directly image exoplanets. We can actually see these things at last, rather than inferring their presence in these indirect ways.
So, Paul, why don't you show us what one of these curves look like for an adaptive optic system? So what we're plotting here is you look at a star, and you plot how bright a planet you could see, or it's essentially how much fainter than the star you could see as a function of separation. And so we plotted these things in the lovely units of Hipparcos called magnitudes. And essentially a magnitude is that when you have 5 magnitudes, you have a factor of 100. 10 magnitudes, a factor of 100 times 100, or 10,000, and so on. So it's a logarithmic scale. So I note here that we're sort of bottoming out at about a factor of, that's 100, so a factor of a couple hundred, 300, and...
So saying that we can see things at the separation, so that's half an arc second, that's 1 arc second. So something's half an arc second away, we can only see it if it's no more than maybe 200 or 300 times fainter than the star.
Right, and we know we need to do a lot better than that. We're talking we need factors of 1 billion or something, right? So we're not even close yet.
In fact, we don't even have trouble seeing the candle and the car headlights.
Yeah.
Of course, they're much further than half an arc second apart from each other, but the contrast ratio gives them trouble. So, are we stuck here? Well, it's clearly time to start cheating, I think.
Yep.
So one way we can cheat would be to look at the infrared. The normal calculation is you get a star, and it's emitting visible light that comes out and reflects on the planet and bounces to us. But in the infrared, if the planet is glowing by itself because the planet is hot, then the star won't be emitting very much light, and the planet will be emitting quite a lot. We've talked about this before. That might give us a bit of an edge.
So we just have to choose hot planets. Now, planets in our own solar system are, I wouldn't call them hot, so we'll have to think a bit about that. I mean, here's Saturn, and it is glowing. It is warm inside due to when it was born, it had all that heat, and it is still glowing. And I guess we can, maybe we should go and figure out exactly how that process occurs.
Yeah, so the idea is, as you can see, this infrared, these things are glowing a little bit, these giant galaxies. That's because of leftover heat from formation.
Yep.
So let's see how hot we'd expect these things to be when they're newly formed.